Welcome dear students, we can see the chapter Mathematical Induction. What is mathematical induction? Before going to solve the problems under this mathematical induction, we can see what is this. Now we consider the sum of n positive odd integers. The odd integers are 1, 3, 5. Here they said the sum of n positive odd integers. So Sn is equal to 1 plus 3 plus 5 plus etc. The nth term here it is 2n minus 1. In SSLC you have studied that the arithmetic progression. There the nth term formula is an is equal to a plus n minus 1 into d. By using that formula, here a is equal to 1. The difference between each term is 2. By substituting a and d in an is equal to n minus 1 into we will get the nth term is 2n minus 1. Therefore Sn is equal to the sum of odd positive integers here equal to 1 plus 3 plus 5 plus etc. plus 2n minus 1. Now we also see the sum of first term. The first term is 1 only. The sum of the first term is itself, and sum of the two terms is the sum of the first term and second term, that is 1 plus 3 is 4, and this 4 can be written as 2 square, and sum of the first three terms are 1 plus 3 plus 5, that is equal to 9, which is equal to 3 square, and so on. We observe here the pattern. S1 is equal to 1, that means 1 square. S2 is equal to 4, means 2 square. S3 is equal to 3 square, which is 9, and so on. So here can we conclude that Sn is equal to its nth term is n square. Now we also see the next, consider Pn, that is P is the prime number. Pn is equal to n square plus n plus 41. Is Pn a prime number for every natural number n? We verify that when n is equal to 1, P1 is equal to 1 plus 41, that is equal to 43, and P2 is equal to n square, 2 square is 4 plus n is 2 plus 41 is equal to 47, and P3 is equal to here 3 square is 9 and plus 3 plus 41 is 53, and so on. Here we observe that all these 43, 47, 53 and so on are all prime numbers. We also observe that just because the given statement is valid for all the n is equal to 1, 2, 3, 4 etc. up to m, but we cannot conclude that this statement is true for all the positive integers n. To prove that a statement involving n here, the nth term, here is we have a nth term, and also in the prime number Pn is equal to n square plus n plus 41 and many more. Here the statement involving n is true for all n which is belonging to the set of naturals. The following principle, the principle of mathematical induction here now we introduce, can be applied. Now we see the principle of mathematical induction. The mathematical induction shortened as MI. So principle of mathematical induction. What is this? The given statement whatever, we can take a P of n with a certain formula or the statement involving n. In the previous I said that is sum of n terms of the n positive odd integers, that is Sn is equal to 1 plus 2 plus 3 plus etc. plus 2n minus 1, that is P of n. Then P of n holds for all the positive integers n if first we satisfy whether P of 1 is true. If P of 1 is true, then we assume P of m, and which should implies P of m plus 1. So related to this we can see the problem. Now question number 1, prove that 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 by 2 by the principle of mathematical induction. We said the principle states that first we can take the given statement as a P of n, then a P of n is 1 plus 2 plus 3 plus etc. plus n, that is equal to n into n plus 1 divided by 2. Now we verify the second one is whether P of 1 is true. P of 1, the left hand side here it is 1 only, is right hand side also 1, that is 1 into 1 plus 1. 1 plus 1 is 2 here, 2 by 2 is 1, therefore left hand side is equal to right hand side, that is equal to 1, hence P of 1 is true. Now we assume P of m, wherever n is here we put it is m, that is 1 plus 2 plus 3 plus etc. plus m is equal to m into into n plus 1 divided by 2, take it as a equation star. Now we also take p of m plus 1. Here wherever m is there, take m as m plus 1. Then it will be p of m plus 1 is equal to 1 plus 2 plus 3 plus etc. plus m is m plus 1. Here this m is m plus 1 into again m is m plus 1 and plus 1 divided by 2. Now this is called the next term of p of m plus 1. This m plus 1 we have to add both right and left hand side of the equation star. So this can be written once again 1 plus 2 plus 3 plus etc. plus m plus 1. You have to add the left hand side's mth term, m plus 1th term to both side of a star. So m plus 1 is equal to here also m into m plus 1 divided by 2 plus m plus 1. Now we simplify this right hand side, should get p of m plus 1's right hand side, that is m plus 1 into m plus 1 plus 1 by 2. So we can see the simplification, that is m into m plus 1 divided by 2 plus m plus 1. The next term we are added here, is it? So simplify this, that is m into m plus 1 plus here the denominator 1 into 2, make the common denominator as 2, then we get it is 2 into m plus 1 divided by 2. Here m plus 1 and m plus 1 both common, keep it outside, then remaining here m plus 2 here, that m plus 2 can be written as m plus 1 divided by 2, which is same as p of m plus 1. Therefore p of m implies p of m plus 1. Therefore by the principle of mathematical induction, p of n, the given statement is true for all n belonging to n. Next question, prove by mathematical induction that the sum of first n odd natural number is n square. Sum of first n odd natural numbers, that is the given statement p of n is on n odd natural numbers are 1 plus 3 plus 5 plus etc. Its nth term is 2n minus 1. We have to prove that is equal to n square. First we verify whether p of 1 is true. Here 2 into 1 is 2, 2 minus 1 is 1. The right hand side 1 square is also 1. Therefore p of 1 is true. Now we assume p of m, that is 1 plus 3 plus 5 plus etc. plus n is m we write. It is same for all the problems. The procedure is same. Hence we have 2m minus 1 is equal to n is m square. Take it as equation star. Now also assume p of m plus 1. Wherever m is there we put it is m plus 1. That is 1 plus 3 plus 5 plus etc. plus 2 into this m is only m plus 1 minus 1 is equal to m is m plus 1 the whole square. Now what is the next term? The next term will be 2 into m plus 1 plus 1. Multiply this. This is 2m plus 2 minus 1 plus 2 minus 1 is a plus 1. Therefore it is 2m plus 1. So the next term will be here, it is 2m plus 1. Add this 2m plus 1 on both side of equation star. So we get 1 plus 3 plus 5 plus etc. plus 2m minus 1 plus 2m plus 1 will be the next term, is equal to m square plus 2m plus 1, which is equal to m square plus 2m plus 1 is what? It is m plus 1 the whole square, because it is in the form of a square plus 2ab plus b square, that is a plus b the whole square, which is p of m plus 1's right hand side. So which is p of m plus 1. Therefore p of m implies p of m plus 1. Therefore by the principle of mathematical induction, p of n is true for all n belonging to n. Now we can see the next question, number 3. Prove that 1 square plus 2 square plus 3 square plus etc. plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6. That is sum of the square of natural numbers is equal to n into n plus 1 into 2n plus 1 divided by 6 by the principle of mathematical induction. Given statement always we can take it as a p of n. Verify p of 1 is true. Here n square means 1 square. The right hand side is 1 into 1 plus 1 is 2 into 2 into 1 is 2 plus 1 is 3, 2 3 is 6 divided by here it is 6. So 6 by 6 is 1. Therefore p of 1 is true. Now also assume P of m, that is m square is equal to, in the place of n it is m into m plus 1 into 2m plus 1 divided by 6, take it as equation star. Now P of m plus 1, m is m plus 1, here this m is m plus 1 into m plus 1 plus 1 into 2 into, only m is m plus 1 and plus 1 divided by 6. Add the next term here it is m plus 1 the whole square on both side of star, so that 1 square plus 2 square plus 3 square plus etc. plus m square plus m plus 1 the whole square is equal to m into m plus 1 into 2m plus 1 divided by 6 plus m plus 1 the whole square. Here m plus 1 and m plus 1 the whole square. Here m plus 1 is common, keep it outside, then remaining here m into 2m plus 1 plus take the common denominator. Here denominator 1 into 6 into 6. So 6 into m plus 1. Now simplify this. M plus 1 into m into 2m is 2m square, m into 1 is m, and 6 into m is 6m, 6 into 1 is 6. Simplify this again. 2m square, m plus 6m is 7m plus 6. Now splitting the middle term, or by we have to factorize this. 2 6 are 12, so 4 3s are 12 and 4 plus 3 is 7. So we can take the splitting of the middle term is 4 plus 3. Hence we have m plus 1. Here 2m is common. 2m into m plus 2 here, plus here 3 common, m plus 2 here. So m plus 2 into m plus 2 is m plus 2, 2m plus 3 here, that can be written as m plus 1 into m plus 2 can be written as m plus 1 plus 1, that is m plus 1 plus 1. 2 into 2m plus 3 can be written as 2 into m plus 1, that is 2m. 2 into 1 2 plus 1 is 3 here, which is same as P of m plus 1 here. So P of m implies P of m plus 1. By the principle of mathematical induction, P of n is true for all n belonging to n. Question number 4. Prove by mathematical induction 1 cube plus 2 cube plus 3 cube plus n cube is equal to n square into n plus 1 the whole square divided by 4. Here the sum of the cube of the natural numbers, positive natural numbers, is equal to n square into n plus 1 the whole square divided by 4. Now the given statement is always P of n. Verify P of 1. The left hand side is 1 cube is 1, and here 1 into 1 plus 1 is 2, 2 square is 4, 4 into 1 is 4 by 4 is again 1. Therefore left hand side is equal to right hand side, hence P of 1 is true. Assume P of m, wherever n is there you can take it as it is m, take it as equation star. Now P of m plus 1, m is m plus 1, m is m plus 1 the whole square into this m is m plus 1 and plus 1 the whole square divided by 4. The next term here will be m plus 1 the whole cube. We add this next term on both sides of equation star, so that we get 1 cube plus 2 cube plus 3 cube plus etc. plus m cube plus m plus 1 the whole cube is equal to here m square into m plus 1 the whole square by 4 plus next term is m plus 1 the whole cube. Once again here m plus 1 the whole square, m plus 1 the whole cube. So m plus 1 the whole square is common, keep it outside. Then remaining here m square plus another m plus 1 is remaining, and also it has denominator 1, making the common denominator as into 4 into 4. So 4 into m plus 1. Now simplify. M square plus 4 into m is 4m plus 4 into 1 is 4, and this will be m plus 2 the whole square, that this is of the form a square plus 2ab plus b square. Therefore it is a plus b the whole square. So here b is 2 square, b square is 2 square, that means b is 2. That 2 can be written as here m plus 1 the whole square, which is same as here P of m plus 1. Therefore P of m implies P of m plus 1. Hence by the principle of mathematical induction, P of n is true for all n belonging to n. Next question number 5. Prove that 1 into 2 plus 3 into 4 plus 5 into 6 up to n terms is equal to n into n plus 1 into 4n minus 1 divided by 3. Here we have not given the n terms. Therefore, here the two factors are given. The first factor is 1 plus 3 plus 5 etc. n, and the second factor is 2 plus 4 plus 6 plus etc. up to n. Now here we have to find the nth term by using arithmetic progression. So nth term formula, an is equal to a plus n minus 1 into d. See the first factor, 1 plus 3 plus 5. It is the sum of the odd positive natural numbers. We already seen that its nth term is 2n minus 1, and the sum of the even positive natural number is the nth term is 2n. Here it is multiplied. Both odd and even natural numbers are multiplied. Hence we multiply their nth term also. We get 2n into 2n minus 1 or 2n minus 1 into 2n, which is p of n is equal to n into n plus 1 into 4n minus 1 divided by 3. Now we verify whether p of 1 is true. The left hand side is 2 into 1 is 2 into 2 into 1 is 2 minus 1 is 2. So therefore this is 2 here, and also 1 here 1 into 1 plus 1 is 2 into 4 ones are 4 minus 1 is 3 divided by 3. 3 cancel, it is 2. Therefore left hand side and right hand side both equal to 2. Hence p of 1 is verified and p of 1 is true also here. Now also p of m we can take. In the place of n we have to write it is m. Therefore we have 2 into m minus 1 into 2m, or we can write 2m into 2m minus 1 is equal to n is all n's are replaced as m. Therefore it will become m into m plus 1 into 4m minus 1 divided by 3. Take it as equation star. Now the next term p of m plus 1, in the place of m we put as m plus 1, that is 1 into 2 plus 3 into 4 plus 5 into 6 plus etc. plus 2 into m is what? M plus 1 here into 2 into this m is m plus 1 minus 1 is equal to m is m plus 1, m is again m plus 1 plus 1 into 4 into m plus 1 minus 1 divided by 3. Now the next term is here 2 into m plus 1. This we simplify that. 2 into m is 2m plus 2 minus 1, that is plus 1. That is 2 into m plus 1 into 2m plus 1 is the next term. We have to add both sides of equation star. Then 1 into 2 plus 3 into 4 plus etc. 2m into 2m minus 1 plus 2 into m plus 1 into 2 into m plus 1 minus 1 is equal to m into m plus 1 into 4m minus 1 divided by 3 plus 2 into m plus 1 into 2 into m plus 1 minus 1. That is m into m plus 1 into 4m minus 1. Here the denominator is 1, making the common denominator by multiplying into 3 here. That is 3 to the 6 into m plus 1, and this will be simplify this. 2 into m is 2m, 2 into 1 is 2 plus 2 minus 1 is plus 1, it is 2m plus 1 whole divided by 3. That is here m plus 1 and m plus 1 is the common term. In these two terms m plus 1 is common. Keep it outside. Then we have remaining here 4m minus 1 and m, that is 4m square minus m. Here it is 6 into 2m is 12m, 6 into 1 is 6. Here m plus 1 already taken as common, which is outside. Now it will be m plus 1 into 4m square plus 12 minus 1m is plus 11m plus 6 divided by 3, which is m plus 1 into 4m square. Splitting the middle term or factorize this quadratic expression, that is 4m square, 4 6 24, therefore 8 3 is 24, 8 plus 3 is 11 we will get. So we choose the factors of 24 are 8 and 3 here. Hence it can be written as 4m square plus 8m plus 3m plus 6 whole divided by 3, which is equal to m plus 1 into 4m. In these two terms 4 common and 1 m common, so 4m common. Here we have m plus 2 plus 3 common here, 3 into m plus 2 divided by 3, which is equal to m plus 1 into again here m plus 2 common, remaining 4m plus 3 divided by 3, that is m plus 1. M plus 2 can be written as m plus 1 plus 1, and 4 into 4m plus 3 can be written as 4 into m plus 1. See, 4 into m is 4m plus 4 into 1 is 4, but we want here 3. We subtract 1, that is minus 1, which will be same as p of m plus 1. Therefore p of m implies p of m plus 1. Then by the principle of mathematical induction, p of n is true for all n belonging to n. Next, question number 6. Prove by mathematical induction 1 cube plus 3 cube plus 5 cube plus etc. plus 2n minus 1 the whole cube is equal to n square into 2n square minus 1. This is the sum of the cube of the odd positive natural numbers is equal to n square into 2n square minus 1. This we have to prove by the principle of mathematical induction. Okay, the given statement is a p of n. Now we verify p of 1, that is 2 into 1 is 2 minus 1 is 1, 1 cube is 1, and here 1 square is 1, 2 into 1 square is 2 minus 1 is 1 again. So the left hand side is equal to right hand side, both equal to 1, hence p of 1 is true. Now we assume p of m, wherever n is there, we put it is replace as m, that is 2m minus 1 the whole cube is equal to m square into 2m square minus 1. Take it as equation star. Now also assume p of m plus 1, which is 1 cube plus 3 cube plus 5 cube plus 2 into m is m plus 1 minus 1 the whole cube is equal to m is m plus 1 the whole square into 2 into m is m plus 1 its square means whole square minus 1. Now the next term will be here 2 into m plus 1 minus 1 the whole cube. We add this one to both side of the equation star. Then we get 1 cube plus 3 cube plus 5 cube etc. plus 2m minus 1 the whole cube plus this we simplify. 2 into m is 2m, 2 into 1 is 2, plus 2 minus 1 is plus 1, so 2m plus 1. The next term after simplified form it will be 2m plus 1 the whole cube, that is equal to m square into 2m square minus 1 plus 2m plus 1 the whole cube, that is equal to m square into 2m square minus 1 plus here we use the form, this is of the form a plus b the whole cube. What is a plus b the whole cube? A plus b the whole cube is a cube plus 3ab into a plus b plus b cube. By using that formula we expand this, that is a cube 2m the cube is 8m cube, 3ab 3 into 2m into 1 into a plus b is 2m plus 1 plus b cube is 1 cube, that is m square into 2m square is 2m power 4, m square into minus 1 is m square plus 8m cube plus 3 2s are 6, 6 2s are 12 m square, m into m is m square, again 3 2s are 6, 6m into 1 is 6m and plus 1 cube is 1, that is 2m power 4 plus 8m cube plus 11m square plus 6m plus 1. Now we factorize this by splitting its relevant middle terms, that is 2m power 4, 8m cube can be written as 2 related which is shifted to the same coefficient, that is 2 and 2, and here the 2 plus 8, 2 plus 6 is 8. Again it is splitted, the 11m square is also splitted the two terms, that is 6m square plus 5m square, and 6m is also splitted as 2 terms, that is 5m plus m plus 1. Now considering these two factors in each case, here 2m cube common, remaining m plus 1, because here we note that m plus 1 is the factor of these terms. Therefore 2m cube into m plus 1, and here 6 common and m square common, remaining m plus 1, here 5 common and m common, m plus 1 and m plus 1. So all these terms containing m plus 1 as a common term, therefore keep it out or take it as a common, m plus 1 into remaining 2m cube plus 6m square plus 5m plus nothing is there means 1. Again it is a cubic equation. We factorize by splitting the middle term, splitting the terms. M plus 1 into 2m cube plus 6m square can be written as, if we settle this 6 to 2, then this will be 2m square plus remaining is 4m square. Again connect to 5, that is 4m plus m plus 1. Now factorize here these two terms, these two and these two. Identify the common factors. Here 2m square common, remaining m plus 1 and plus 4m is common, m plus 1 and m plus 1. Again m plus 1 is common, that m plus 1 is already is present outside, then m plus 1 into m plus 1 is m plus 1 the whole square, remaining 2m square plus 4m plus 1, which is equal to m plus 1 the whole square into 2 into m square plus 2m plus 1, because 2m square plus 4m plus 1 it can be written as 2 into m square plus 2m, that will become 4m plus 1, which is same as m plus 1 the whole square into 2 into m plus 1 the whole square. If we make this as m plus 1 the whole square by adding 1 here, m square plus 2m plus 1 is m plus 1 the whole square, but also we have to subtract 1, hence it will become minus 1, which is p of m plus 1. Therefore p of m implies p of m plus 1. Therefore by the principle of mathematical induction, p of 1 is true for all n belonging to n. Next we see the question number 7. Prove by the principle of mathematical induction 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 plus etc. plus 1 by 3 into 3n minus 1 into 3n plus 2 is equal to n by 6n plus 4. Okay, now we see the answer. Proof. Let the given statement be p of n. Verify p of 1 is true or not. Here 1 by 3 into 1 is 3. 3 minus 1 is 2 and 3 into 1 is 3. 3 plus 2 is 5. So 2 into 5 is 10 here. 10, and the right hand side it is 1 by 6 into 1 is 6. 6 plus 1 is 4 is 10. So 1 by 10. Therefore left hand side and right hand side both equal to 1 by 10. Therefore p of 1 is verified. Now we assume p of m, that is 1 by 2 into 5 plus 1 by 5 into 8 plus etc. plus 1 by m. Here n is m, that is 1 by 3m minus 1 into 3m plus 2 is equal to m by 6m plus 4. Take it as a equation star. Now p of m plus 1, that is 1 by 3 into m is m plus 1 minus 1 into 3 into m is m plus 1 plus 2 is equal to m plus 1 by 6 into m plus 1 plus 4. Add the next term 1 by, this will be the next term. Now add this next term to both side of equation star, so that we get 1 by 2 into 5 plus 1 by 5 into 8 plus etc. 1 by 3m minus 1 into 3m plus 2 plus 1 by 3m plus 2. We simplify the next term, that is 3 into m is 3m and 3 into 1 is 3 plus 3 minus 1 is plus 2, that is 3m plus 2, and here 3 into m is 3m, 3m plus 1 is 3m, 3 into 1 is 3 plus 2 is 5, that is 3m plus 5, which is equal to the right hand side of star is m by 6m plus 4 plus 1 by 3m plus 2 into 3m plus 5. That is equal to m by 2 into m plus 2, 3m plus 2 plus 1 by this 6m plus 4 can be written as 2 is common, then remaining here 3m plus 2 plus 1 by 3m plus 2 into 3m plus 5. Here it is 3m by 2, here also 3m plus 2, therefore 3m plus 2, 3m plus 2 common in these two terms, we can take it as common out, that is 1 by 3m plus 2 into here remaining m by 2 plus 1 by 3m plus 5. Now once again considering the LCM, here it is into 3m plus 5 and here also into 3m plus 5 and here it is into 2 and here it is into 2, so that we get m into 3m is 3m square plus m into 5 is 5m plus 2 into 1 is 2 divided by 2 into 3m plus 5 is 6m plus 10, that is equal to 1 by 3m plus 2 into 3m square plus split the middle term 3m plus 2m plus 2 divided by 6m plus 10, which is equal to 1 by 3m plus 2, 3m, here 3 common and m common, remaining here m plus 1 and here 2 common, again m plus 1, so m plus 1 be the factor here divided by 6m plus 10. that is equal to 1 by 3m plus 2 into 3m plus 2 into m plus 1. These factors divided by 6m plus 10. That is equal to m plus 1. Here we have 3m plus 2 and 3m plus 2 getting cancelled. Then remaining m plus 1 divided by 6m plus 10. That can be written as m plus 1 by 6 into m plus 1 plus 4, because we should get same as 10. Therefore we have to adjust, add 6 into m plus 1. 6 into 1 is 6 plus 4 is 10. The same thing we will get. Therefore we can write according to p of m plus 1, it will be m plus 1 by 6 into m plus 1 plus 4, which is p of m plus 1. Therefore p of m implies p of m plus 1. Hence by the principle of mathematical induction, p of n is true for all n belonging to n. Next, question number 8. Prove that 1 minus 1 by 2 square into 1 minus 1 by 3 square etc. into 1 minus 1 by n square is equal to n plus 1 divided by 2n for all n greater than or equal to 2 here, where all n belonging to n. Okay, the given statement is p of n. Now we have to verify p of 2 here, because it is given that either n is greater or equal to 2. Therefore we verify, instead of p of 1 it is p of 2. The condition is given here, n is greater than or equal to 2. So p of 2 here, 1 minus 1 by 2 square. 1 by 2 square is 4 it is. So 4 minus 1 is 3 by 4. The right hand side, 2 plus 1 is 3 and 2 into 3 is 6. That is equal to 3 by 2 plus 3 by 4. So 3 by 4 here, which is the left hand side and the right hand side both equal to 3 by 4. That is equal, therefore p of 2 is true here. Now assume p of n, m, that is 1 minus 1 by 2 square into 1 minus 1 by 3 square etc. 1 minus 1 by m square. In the place of n it is m, because we have already a practice of replacing n as m, and also by considering the m plus 1th term and also adding the next terms. So the same thing repeating in all the problems of this principle of mathematical induction here, that is 1 minus 1 by m square is equal to m plus 1 by 2m. n plus 1 is m plus 1 by 2m. Take it as a star. Now the p of m plus 1 is 1 minus 1 by 2 square into 1 minus 1 by 3 square etc. 1 minus 1 by m is m plus 1 the whole square is equal to m is m plus 1 by 2 into m plus 1. Now what we can do here, we could not multiply, we should not add the next term, but instead we multiply the next term. Why we multiply the next term? Because the statement given as here, into each term by into 1 minus 1 by 2 square into 1 minus 1 by 3 square is given. If it is differed by positive, then we say add the next term. Here it is multiply, therefore multiply the next term 1 minus 1 by m plus 1 the whole square on both sides of a star, so that we get 1 minus 1 by 2 square into 1 minus 1 by 3 square is etc. 1 minus 1 by m square into the next term is 1 minus 1 by m plus 1 the whole square is equal to m plus 1 by 2m. The equation star is m plus 1 by 2m into 1 minus 1 by m plus 1 the whole square. That is equal to, simplify the right hand side of p of m plus 1, which is m plus 1 by 2m. Here this has a denominator 1. By considering the common denominator as m plus 1 the whole square, so we need to multiply this m plus 1 the whole square here. So m plus 1 the whole square minus 1 divided by common denominator is m plus 1 the whole square. Here we have m plus 1 and another m plus 1 are getting cancelled. Here we have the 2m plus 1, that is m plus 1 the whole square. So each factor getting cancelled. So therefore remaining here m plus 1 plus 1 into this we consider 1 square, that is of the form a square minus b square. What are the factors of a square minus b square? Is a plus b. A is 3m plus 1 plus b is 1. Again into a minus b. A is 3m plus 1 minus b is 1 divided by 2m into m plus 1, which is here plus 1 minus 1 cancel, only m remaining. That m is cancelled with this m. Then remaining m plus 1 divided by 2 into m plus 1, which is same as p of m plus 1. Therefore, p of m implies p of m plus 1. Hence, by the principle of mathematical induction, p of n is true for all n belonging to the set of natural numbers.